These are the video notes for section 2.3, parallel and perpendicular lines. And today we're going to just really extend the ideas of 2.1 and 2.2, which we're writing equations in slope-intercept and point slope, and transfer that idea to how we work with parallel and perpendicular. Also, we'd like to talk about numbers of solutions, or certain types of solutions based on looking at a pair of lines, whether that is they cross, they don't cross, or they're the same line. So we'll get into all that in just a bit. But let's start out with just a little bit of kind of refresh and build in the idea of parallel and perpendicular from the earlier parts of the chapter. So as a reminder, some of the forms, so point slopes, working off of equation 1, what we're going to do is we're going to count the slope from the graph, and then we're going to pick one of our points and go ahead and run point slope. So if I count my slope from dot to dot, going left to right across the page, that would be down 3 over 2, so I know the first one has a slope of -3/2. Now, as far as y-intercept goes, I can tell where my y-intercept is at. Y-intercept is up there at counting by, so it's at 5, so my y-intercept there is at 0.5. So really, I could do my slope-intercept form right away because y-intercept is b, so y is equal to -3/2 x plus 5. As far as point slope goes, I'm going to practice that with a different point, not the y-intercept. So let's use this coordinate right here, which is 4, -1. And I could use this one as well. I could even use the y-intercept, actually. But, so we're not plugging in 0, just so we can see another version of it. So let's say I use the 4, -1, and I would go y minus my y, so y minus a minus is plus. I know my slope is -3/2. And then x minus my x value, which is 4. And remember that you can convert from one to the other just by distributing into the parentheses and then getting y by itself. So let's say I did that, just so you can see that work. If I distributed on the right side, I'd have -3/2 x, and then 3/2 times 4 would be -6. And then all I'm going to do basically is, that's negative, positive 6 there. And then subtract that 1 over, and I would be in the same spot. So you can convert from point slope to slope-intercept just by distributing and then solving that equation for y. Now, other things we want to introduce today is the concept of a parallel line. So parallel lines have a characteristic that's unique to them compared to their original line, which is what's true about their slope. And really, this is easy enough to figure out if you just understand that parallel lines do not cross. So you can visualize parallel lines not crossing. So that means parallel lines would have to have the same slope. So if their slope is the same, there's no way for them to cross. So, compared to the original, slope is definitely the same with parallel lines. Now what is different? Well, they actually are crossing the y-axis at a different spot. They'd have to be parallel, not cross, but eventually, of course, both lines will go through the y-axis. So a different y-intercept. So what's different is the y-intercept. Would they ever intersect? And that's a big no, because parallel lines having the same slope, there's no way for them to slowly slant towards each other and cross. That's a big no. Write the equation of the parallel to the original going through the graph at a given point. So we're going to write that equation of the line parallel to the original going through the given point. Now in this case, the given point is actually what's just sitting up there, so I have to grab that point. I'm going to go with this one, which is at 2, looks like 2.6. So we're going to go 2.6. We got that down up there just so you can see it. Just move that one off for a minute. So right here is 2.6. So with a point and a slope, and we know the slope is the same, so really down here we can just jot down exactly the same slope that we figured out before, which was -3/2. But my coordinate that line goes through was 2.6 up on my graph. So now I'm going to go y minus y. We're going to start out in point slope, so y minus 6, -3/2, x minus 2. Now what we're going to do is solve it and just compare it to the actual graph, and we'll see what's going on with y-intercept. So Solving it for y should change us into slope-intercept. So now we're in point slope. We're going to multiply 3 halves in, the negative 3 halves in. We'll go into some small steps here. So negative times negative is positive. The 2's would actually cancel out, so that would be 3. And then add your y to the other side. Sorry, excuse me, add that number to the other side. Now, if I compare that equation to the one in green up there, that actually is a y-intercept up there of 9. So now I can see that that line that's graphed matches what I have, y equals mx plus b, even though I started out in point slope. So the red equation from number 2, excuse me, the green equation from number 2 and the red equation from number 6 are parallel lines, different y-intercepts, but same slope. Okay, let's check out perpendicular. So again, we're going to start with, I think we'll start with number 2 because that's sort of what's staring at you. So if you count your slope, and by the way, that point's a little bit off. I'm going to just kind of darken it. It should be sitting right there. But if I count, that's up 1, 2, 3, 4 over 1, 2. So a slope of up 4 over 2 is a slope of 2. 4 halves is 2. And y-intercept is at 0, 4. So things that I know now are what is my slope and what is my y-intercept. So I can write my equation in slope-intercept. So we're going to go mx plus b. Then I'm going to switch back up to point slope. And again, we'll do that kind of conversion where we switch it over from one to the other by just doing a little bit of solving for y. So we're going to do the slope of this one, and we're going to use the same slope, but I'm going to pick a different point. The point that I'm going to pick will be this one here, which is negative 2, 0. So if I use that coordinate, I would go y minus y, so y minus 0 equals slope. X minus the minus 2 would be plus 2, and then really that one is not much of a leap. All you got to do is drop the 0 off and distribute that 2 in. So very easy to change one to the other. Just distribute the slope into the set of parentheses and then move your number term over, which in this case I didn't have to do because it was 0. And I can sort of prove to myself that those are actually the equation of the same line, just in different forms. Now, perpendicular is a little bit different idea. I'm going to pop up the perpendicular line. So when we have slopes that are perpendiculars, they're actually called opposite reciprocals. But if you count that slope, the red line that I popped up, it is down 2 over 4. Which is negative 1/2. Now let's compare the slopes for a second. So first of all, what would be the slope of the perpendicular line? It would be negative 1/2 by counting. In comparison, if you look at 2 over 1 and negative 1 over 2, the relationship is what we call an opposite reciprocal. I'm just going to abbreviate that a little bit, opposite reciprocal. What it means is opposite is a sign change, so this is positive, this one is negative. Reciprocal is flip your fraction over. Whole numbers we consider to be over 1, so if it's 2 over 1, its reciprocal is going to be 1/2. That's a connection that we need to make. It's important to know that's the case between the original line and a line perpendicular to it. Do they intersect? Well, obviously they do, right? And then write the equation of the line perpendicular to the original going through the given point. The given point that I'm going to use is this one right here, which is 4, 2. So we're going to start out in point slope, then we're going to turn into mx plus b just like we did before. I know I have a slope of negative 1/2. And I have my point that I'm going to use, which is 4, 2. So we're going to start by doing y minus y, negative 1/2 x minus x. That would be point slope, so I'd be done if the direction said point slope, and I'm going to do a little bit of converting here. And negative 1/2 times negative 4 would be a positive 2. And the last thing to do would be get y by itself. So there's my perpendicular line in 2 different formats, right? So point slope, slope intercept. And if I go check it out, I can see that it crosses at 4 up there with a slope of negative 1/2. So things to take out of our first 2 slides basically are what's the connection to parallel lines and slope, which is the same. The connection to a perpendicular line, its original is opposite reciprocal. And if we have those two facts down, the rest of it's equation writing, which we've done. That was 2-1 and 2-2. We've done plenty of equation writing. And then this last one is just to talk about something that's unique when you have a line that's basically the same identical line. How do you talk about how they're related by numbers of solutions? Where do they intersect? If we do this line in point slope, let's count the slope. So we have up 1/3, so a slope of 1/3. And we have a y-intercept at -3. If I was doing this in slope-intercept y equals mx plus b, I would just be -1/3 x minus 3. Point slope, again, if I pick this coordinate over here, which is 3, -2, and I'm purposely not choosing the y-intercept to do point slope because that would get you there with a 0 in there. We kind of want to see the process where we don't have 0 plugged in. But still using the same slope, so now I would do y minus a -2, which is +2, and then 1/3 x minus 3. Well, again, if I go to distribute the 1/3 in, I have 1/3 x minus 1, and then I add that 2 to the other side. Sorry, subtract that 2 to the other side, and there we go, a little bit of quick conversion. So I can basically prove to myself that, yeah, that's really the same line again with just a different way of approaching it. One from point slope, one from y equals mx plus b slope intercept. What would be the same with line identical to the original? And so if you had a line that was actually identical to the original, it would really sit right on top of it. Now we can kind of slide this way, or we can slide this way, but the idea again is if it was the same, what would be the same? If it was the same line, what would be the same? So what we're going to do there is we're going to go ahead and just talk about it as, well, clearly they have to have the same slope and same y-intercept. What would be different from the original? Absolutely nothing. Do they ever intersect? This one kind of can mess with your head a little bit, but the answer is actually yes. But not at a single point. They intersect everywhere. So, the difference here is just talking about how many solutions, basically. And if they intersect everywhere, it's not one common point, it's all points in common. We'll get to that in a minute. All right, let's kind of finish up here with a couple last little ideas. All right, so let's do a wrap-up of just the two major ideas here. We're going to talk about parallel, perpendicular, and slope, and then the last thing we'll do is we'll hit the idea of types of solutions one more time. So, first of all, just to kind of practice picking them out by the slope. If you look at pairs of equations we can draw from this list, try to get some ones that are parallel, perpendicular. Let's go parallel first. So what you want to look for is slopes that are identical with different y-intercepts. So for example, 2x, 2x, but 3 and 4. So A and B would be a good choice. Same slope, different y-intercept. Perpendicular should have opposite reciprocals. So if I'm looking for a pair there, I'd want like 2 and -1/2 or -2 and +1/2. So there are a couple pairs here. We could do A and E because that's +2 and -1/2. We could also do B and C because that's -2 and +1/2. In perpendicular, we're not too concerned about y-intercept. It's about the slopes being opposite reciprocals. In parallel, they have to have the same slope, and you have to make sure they had different y-intercepts, to be clear on that. So again, you can pick it out just by focusing on slope, which is what we're going to do for our last question here. So for these, what we really need to do is get them into y and mx plus b to figure out what's going on, because it's hard to see as is. So I'm going to do a little bit of quick solving here. So how was that for some quick solving? So here's what we're going to do real quick. We're going to make a comparison. So different slopes. And what I did was solve each equation for y all over the place here. Different slopes are going to cross in one spot. That's one unique solution. Slopes that are identical but different y-intercepts, they're parallel, no solution. And then when I solved these two equations, I actually got an identical equation. So the fact that the equation was the same equation, the same exact line, they share every point in common, that's infinitely many. So you have to solve them for y, focus on the slopes, and then compare and see what you have for type of solution.